Welcome and study with Tanzania Institute of Education.
Hello, my dear students. My name is Ali Omar Masoudi. I'll be with you in a chemistry subject for Form 2, and our topic is atomic structure. Atomic structure, let us see what is atom first and where this atom coming from. Well, the atom is a small, indivisible particle that can take part in a chemical reaction. Okay, my dear student, the meaning of the word atom is a small indivisible particle that can take part in a chemical reaction. So, where this atom is coming from, and from the different scientists, Dalton, who was the familiar on atom, who reviewed the idea of a Greek philosopher. This Greek philosopher provided the idea that matter is made up of small particle. From this small particle, who the Greek philosopher said about the matter is made up of a small particle, and then Dalton, who came after 2,000 years. After 2,000 years, Dalton came to review this idea because this philosopher did not do any experimental evidence to support his idea. So, what happened later? It gave the Dalton to do an experiment who reviewed the idea of matter is made up of small particle. These particle, according to the Dalton who did the experiment, he saw that it is this atom bring about the formation of matter. So Dalton finally concluded that the matter is made up of tiny particle called the atom. After that, Dalton gave the theory that called Dalton's atomic theories. Dalton's atomic theory was the contribution, a big contribution for the discovering of the atom. The Dalton atomic theory was discovered in 1803. In 1803, my dear student, you can't separate atom with Dalton's idea. It was Dalton's idea. Now we have a several number of atoms. Was used this idea to have an atom. What the idea said the atom? Okay. Dalton said that, what the idea said Dalton about the atom? Dalton said that matter is made up of smallest indivisible particle called the atom. This was the first idea which Dalton worked on about the atom. And another idea of the Dalton was this atom. He said this atom can neither be created nor destroyed. Can neither be created nor destroyed. Another idea of Dalton, my student, was another idea. He said that atom of the same element are atoms of the same element are identical in all respects, in all aspects. Dalton said that atoms of the same element are identical in all aspects. And another one, Dalton said that atoms of different elements atoms of different elements are differ in all aspects. Are we together, my students? Okay, let us come to the first one idea. Matter is made up of a small indivisible particle called the atom. Let's say this is aluminum foil. Aluminum foil is made up of aluminum atom. It is large in size. But the size of this aluminum foil, there are small particles of aluminum atom that made it. And another one, this is a 100-shilling coin. 100-shilling coin is made up of small particles that concentrate together, which is a copper. Copper atom, it made this 100-shilling coin. And now let's see this. This is a bottle, top bottle. This is made up of small particle of iron atom. My students, now you will see in your surroundings a lot of things that has been made up of small particle. When we say a small particle, if I can take this as a piece of foil and I can cut this and again, I cut this again, I cut this again, and I cut this again, I will remain with this very, very, very small particle which can't be cut again. So that a small particle is what we say atom. Okay? That's fine. Another one. He said that atom can neither be created nor destroyed. You can't create atom of this aluminum foil. If you have a big one like this, if you cut this, it will remain to be aluminum. And if you break down this top bottle, it will remain iron and is not another atom. It is not another atom. You can't break down, even though if you cut down this, it will remain that is an iron. And another one, atom of the same element are identical in all aspects. When we say in all aspects, what do you mean? Okay, we mean that When you say in all aspect, if there is a color of this atom, will remain with that color. If there is harder in nature, will remain with that character in nature. The same atom example sorry, I have just rubbed the topic. I'll write it again. Atomic structure to remind you that we are in atomic structure. Example, atom of the same element. Let's say I have a gold. I have a gold. A gold can be, we can create it a chain of gold, or we can create it a ring of gold. Ring of gold. But it will remain to be what? To be a gold. Will never change the nature of the gold. It will remain a gold. And if it is a iron, we can have it, we can make it several things, several things of iron. You can make it surrounding at your home. But it will never change to be another form. It will remain to be iron. Am I clear, my students? Okay? Now, there is another one, which is atom of different element are differ in all aspects. Yes, atom of different element are differ in all aspects. Let's say this is aluminum foil. It's different with this copper atom, copper coil and aluminum foil. This is made up of aluminum atom and this is made up of copper atom. So they are different. They are different in color. They are different even in structure. This one is very hard and this is very soft. That's all. The last one on which Dalton said, he said that atom can combine with another atom to form in small ratio to form a compound. You see, when we say about a small ratio, what we mean? Small ratio, it means 1:1, 2:2, 1:3. That is a small ratio. So, Dalton, his idea was never suggested that there will be anyone can see the atom. And he feel that all this idea is correct. However, the modern technology came to do further experiment on the idea of what? On the idea of Dalton. He saw that. They saw that these scientists from modern technology, they came to modify all this Dalton's atomic theory. Okay. They came to modify and see that there were some of the mistake made by Dalton who share this idea. So Dalton, about what he said, from the first of the idea of Dalton that matter is made up of smallest indivisible indivisible particle called the atom. Called the atom. The modern scientists, experimental that have been conducted from this theory, from this idea of Dalton, what they saw? They saw that there are some of particle in that atom. And they concluded that the idea, modification of this idea, so that the atom is not indivisible. When we say indivisible, what we mean? You can't break down. So they came to the conclusion that the idea of atom is indivisible particle. There was nearly wrong, since atom consists of the three fundamental particle. These are proton and what? Neutron, very good, and electron, yes, and electrons. These were seen after conducting what? After conducting the experiment to understand what the idea of this Dalton said. No, not only that, when idea came to say that atom can neither be created nor destroyed. Idea that the atom can neither be created nor destroyed, Dalton was not a completely correct. About this, the modern scientists saw that there can be, atom can be created and can be destroyed. Atom can be, what we said? Atom can be created, good. Atom can be created, good, and can be what? Can be destroyed, and can be destroyed. You see, my dear students, atom can be created and can be destroyed. For what? How can we destroy the atom? And how can we create the atom? Atom can be destroyed and created by nuclear what? Nuclear reaction. Very nice. By nuclear reaction. Good. Is anyone can have an example of the nuclear reaction? Yes. Nuclear reaction, there is nuclear fission and nuclear fusion. Very nice. So, what this? Nuclear fission and nuclear fission. It means that in a nuclear reaction, what happened? Well, let us start fission. Fission and fusion. Nuclear fission and nuclear fusion. Example, if I can take uranium-235. Uranium-235 can be destroyed to produce, can undergo nuclear fission. Okay. Can undergo nuclear fission. Good. Can undergo nuclear fission to produce another atom. To produce another atom. Let's say uranium can undergo nuclear fission. Nuclear fission, it breaks down what is fission and what is fusion. Okay, come to that. When we say about fission, fission means separate. Means separate. Splitting up. That is a fission. And we can say fusion. Fusion means fuse together. To fuse together. That means in a heavy metal like uranium undergo nuclear fission to produce another atom. And in fusion, we can have deuterium. We can have deuterium combine with, react with tritium to form helium, undergo nuclear fusion. Undergo nuclear fusion. So from that, we see that the Dalton idea was so far some sort of not correct. This idea came with this one, which is true that this can be created and not this and destroyed. Another one, Dalton said that atoms of the same element are identical. Atoms of the same element are identical. Atoms of the same element are identical. Identical and the identical in all aspects. That was not completely correct. This idea was modified by the term isotope. Very good. By the term isotope. Very good. This isotope what? There are some of the elements, they can have different atoms. With these atoms, they can have different physical and physical properties. Example, carbon, there is carbon 12 and what? Carbon 13. Very good. Carbon 13 and carbon 14. Good. Carbon 14. These are the isotopes of carbon. Very good. These are the isotopes of carbon. And another one, what's another idea of Dalton said? Atoms of different elements differ in all aspects. Atoms of different elements differ in all aspects. This idea, my student, was not completely correct. And what the challenge was made from that idea? Who can say it? Very good. It is about argon, which is 4018, and calcium, which is 4020. This, they can have same mass number. These can have same mass number, but different atomic number. So we claim that it is not true that the atom of different elements differ in all aspects. This aspect, the mass number of these two atoms are the same. Am I clear, my student? Good. And what is another one? The final one? The final one said that atom of one element combined with the atom of another element in what? In what? A small ratio. Good. In a small ratio. Also, this idea was That's nice, but what's the mistake of this idea? Anyone can say something about this? Okay, yes, that is what Dalton forget about. This idea was challenged by the organic compound and the complex compound. That atom they combine in a huge ratio, in a big ratio. Atom can combine in a large ratio like organic compounds and complex compound. Yes, complex compound and organic compound. It is not your level to understand what is organic compound and what is a complex compound. Am I clear? Very nice. So from that, we can say that something about Dalton idea and about modern technology challenge the idea of what? Idea of Dalton. That was very, very, very a big contribution of Dalton. Without him, we can't. We didn't have this idea to be challenged. And now, you students who are with me from the initial of this lecture, from the initial of this lesson, have this question. You can have this question. What is, ask yourself, what is atom? What is atom? Take your fellow and you just sit together and ask about this question. What is atom? And then, one another question. What states 5 Dalton's atomic theory? Atomic theory. Theories. Okay? State 5 Dalton's atomic theories. Clear? And the final question is from the above, from the Dalton's atomic theory, explain on each the modification of the theory. The modification of the theory. The modification of the theory. You can be with your fellow and you will do this question for today. And finally, nothing to say. Here is the end of our lesson of today. Thank you, my students. I will be with you in the next period. Thank you.